Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is given a linked list of zeros, ones and twos, sort it, and it is an easy level problem. We're just going to start with the problem discussion. This particular problem says that we have been given n nodes and all of them are consisting of only 0, 1 and 2, and we have to just sort the linked list. And the interesting part about this question is that the expected time and space complexity both is O of n. We can use this expected space complexity to our advantage, and let's see what we have here. So basically the problem statement is not very difficult. You have been given a linked list like this and you just have to sort it. So what can we do in this particular problem? Let us have a look. So if you have been given a linked list like this, right? So if you have a linked list like this, now what you can do is, if you are allowed to use O of n space, if we are allowed to use O of n space, so what we can do is, let's say this is pointer 1 pointing to this particular node, this is pointer 2 pointing to the second node, pointer 3 pointing to the third node, and pointer 4 pointing to the fourth node, right? So we can store all of these pointers in a data structure like vector or array, right? Once we have all of the pointers in an array or a vector, now we know that each of the nodes has values 0, 1 and 2. So basically the problem is reduced to something like this, that you have been given an array. This is an array of zeros, ones and twos, right? And you start to sort it. Now for the sorting part, this sorting has to be O of n. Now you can sort it in various methods. So the first method is counting sort, right? So this is a very basic sorting algorithm where if the elements or the values in the array is limited, you can use counting sort. So basically what you do is, you will maintain a frequency array. In this case there are 3 elements, 0, 1 and 2, so you can maintain a frequency array of size 3, writing 0, 1 and 2 indexes, and each time you encounter an element in the original linked list, what you can do is, you can just increment their frequency. Let's say their frequency is x, y and z, so you can write 0 x times, then you can write 1 y times, and then you can write 2 z times, right? So this is how you can write all the elements with counting sort, right? Now if you don't want to use this particular method, there is also a very smart method which helps you to sort without maintaining any frequency array. So this method is very popular, where you maintain 3 pointers, I, j and mid, right? So let's say this is an array. This is an array where you have some values. So your I pointer will be in the start, and your j pointer will be at the end, and your mid pointer will be initially with the I pointer as well. So now you're going to traverse the whole array with the help of this mid pointer, right? Now let's say you encounter a 0 at array of mid, right? Let's say that array of mid is equals to 0. Now you already know that 0 has to be present in the front of the array, right? Or in the beginning of the array. So what I'll do is, I'll swap the positions of array of mid and array of I, right? So what this operation will do, it will take my 0 and move it to the frontmost position, right? Now I can just increment my value of I, and I can also increment my value of mid. So once I do this, let's say there was a 0 present here and there was some other element 2 present here. So after one swapping operation, what will happen? 0 will come here and 2 will come here. So this means I am able to put this 0 at the front of the linked list. Now since I will come to the next position, the next 0 that we have will be placed at the second position. Why do I have to increment I? Because now the first position already has a 0 and the second 0 has to be placed at this particular position. So that is why my I pointer will be always pointing to a position where I can place my next 0, right? So this is how I work with the I pointer. Now similarly if I get A of mid is equals to 2, right? So now I know that this particular 2 should be placed at the end of the linked list. So what I can do is, I can swap A of j and A of mid. Now once this is done, 2 will be moved to the end of the linked list, right? So let's say after the swapping operation, 2 will be moved here. So now I want to decrement this value of j pointer and it will come here at this particular position, right? So now what happens, the next 2, whenever we encounter a next 2, it will be placed at this particular position. So similarly to I, which was pointing to the next location where we can put a 0, j will be pointing to a location where we can put a 2, right? So this is how we can solve this problem using 3 pointers, and mid will be always traversing through the whole array. Now if you don't want to do all of this, I believe that counting sort should work. Counting sort should work since we are already using 3 spaces, O of 3, which is a constant space, right? But if you don't want to use this method, you can always store all the nodes in an array or a vector, and then you can apply this sorting mechanism with 3 pointers, right? So this was a very straightforward question. Now let us have a look at the code. So you will see what I have done is I've used the same 3 pointers algorithm, and I created a vector of nodes which is called list, right? Now while my head is not equal to null pointer, I just push back this particular head into my list and I update my head as head.next. Now I initialize 3 pointers, so I will be the pointer, initial pointer, and j will be pointing to the last element, and x will be the mid pointer. So while x is less than equals to j, I check whether the current element or the element at the mid. So instead of taking mid, I have written x here. If that particular data is equal to 0, then I just swap list of x and list of I. So this is a simple swapping operation using a third variable called temp, right? So what I do, I just put the element or the value at list of x in temp, and then I update my list of x data by list of I data, and then I update list of I data by temp. So basically it will just swap the positions at x and I. Now I increment my value of I as well as x. Now if the current data or list of x data is equal to 2, then I have to swap the same element with the j pointer. So this is the same operation, it's just that now I am swapping x and j, and in this case I am going to decrement j. Now if the current element is equals to 1, then I don't have to swap anything. That is why I can just increment the value of x. At the end, I know that my head is present at the list of 0 or the 0th position, so I can return list of 0. So this was all about today's problem of the day. Now let me just quickly submit this and show you that this particular code works. So you see it passes all the test cases and the solution is absolutely correct. And again, you can always use counting sort, but the question mentioned that we can use O of n space. So that is why I told you a method which uses O of n space. That is all for today's video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and you'll be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe later if you don't find the videos interesting. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.